Okay, so you have basic idea of like first order low pass filter, high pass filter, second order. Firstly, like I will explain that. So
You can explain something that about that.
like first for the first order, low pass filter. So that's the I think circuit for that the basic circuit. Here is V input, that is resistance. There is open positive is to the wrong. Okay, so this is the basic circuit for that first order low pass filter, and the transfer function for it is, you know, can you tell? So the transfer function of this that is minus 1 upon 1 plus SCR. The transfer function is that V naught S upon V I of S. So here from here we can find like the output V naught of S is V I of S of 19 upon 1 plus S S C R. Okay.
Which week you are doing? 6.
Yeah.
Week 6.
Week 5 that first order low pass filter. Have you read?
Today we have to do week 7, no?
No, like certain to do that first order low pass filter, second order low pass filter, and some tutorial questions like sort.
Okay, okay, okay.
Sir explained this week 5 and 6.
Yes, we have done and submitted our solution, graded solution.
Like now in live streaming, sir have explained that.
Yes, yes.
So can we do directly questions or like we
Yes,
can
yes.
start with
You can do
or you?
directly question answer.
Okay.
I think you are doing week 7.
No, it is week 5 that lecture 2 first order low pass filters. In lecture 2 it is explained like
Okay, you can do directly question answer.
okay. So that is so we can start with the basic question like so same circuit. Here is V input, here resistor, here amplifier, open output V naught, then capacitor R2, ground 1 kilo ohm that we take, and that takes CS, C is 10, and and we are given frequency FC as 5 kilohertz. Right. So can you tell like what is the value of R2? Can you solve? So we can get, so the formula of FC is 1 upon 2 pi R2C. Okay. FC is given 5 kilohertz. 5 kilohertz is equal to 1 upon 2 pi R2 we have to find and C again 10 nanometers, so 10 into 10 to the power minus 9. Okay. So now 5 kilohertz into 5,000 hertz is equal to 1 upon 20 pi into R2 10 to the power minus 9. So that's R2 will be 10 to the power 9 comes up 20 pi into 5,000. So can you tell me what is the value? So it will come 10 to the 6 upon 314, and this will be 3.318 into 10 to the power 3. It will come. So it will be so it will come 3.18 into 10 to the power 3. So it will be 3.18 kilo. Okay. It is correct
Okay.
or an issue? Therefore, we can do now second any question. So second question you can do like here is a capacitor. So it is 0.1 microfarad. It is R. That is here 50 kilo ohm and its capacitor is 0.1 microfarad. Cutoff frequency is given. Kilohertz. And the ratio of V out by V input is given as -50. So the top V out by V input is given -50. So we have to find the value of R1. Can you tell how we can do it? Like the basic idea?
KCL at, we can do KCL at that negative V minus point.
Here, at that point,
Yeah.
like that. So the current from that. So we take here
Current will
Vx.
go from VI to Vx.
So Vi minus Vx upon here Ri plus
1 by 1 by CS.
1
That
by
will,
C. Okay, C की value we will take equals
and
to
equal to, that
V
is,
naught
yeah.
V minus Vx upon 150 kilo ohm. Okay, this is correct. So V naught V V naught upon that V naught upon V.
It will be V0 minus Vx minus V0.
Like which have done that
Current will
current
go, yeah,
comes
V,
from that
yeah.
equals to
Then
current goes from there. Oh yes, sorry. So Vx minus V. Okay,
yes,
and we know V naught upon Vi value that is -50. So change V naught with Vi. So Vi minus Vx upon Ri plus 1.
you can put Vx equal to 0. Then it will be,
Wait, firstly minus minus plus 50 I on 150. So then Vx will be 0. So then Vi upon Ri plus 1 Cs is equal to 50 Vi upon 150 kilo ohm. Vi in the Vi. Okay. So 150. So 150 kilo ohm is equal to Ri upon Cs. So 150 kilo ohm. C value will be 0.1 microfarad. 0.1 into 20. So then what? How we replace with S? Can you tell?
that will be J omega.
J omega and J omega value 2 pi I have. Okay, so then omega we can find out here. Omega is equal to 2 pi f. 2 pi into frequency we have given that 50 kilohertz. 50 kilohertz. equal 3. So this is equal to 100. What was 5 into 10 to the power 5? So 150 kilo ohm is equal to 0.1 into 10 to the power minus 6 into pi into 10 to the power 5. See. So that is 10 to the so 150 kilo ohm plus that is 10 to the power minus 7. So it upper 100 upon pi j. Okay. Any problem?
Yes, yes.
So from here Ri will be 150 minus 100 upon pi. So we can multiply j down and what? So 150 minus positive goes down, j square is root minus 1, then j is root minus 1, so j square is minus 1, so that is plus 100 j upon pi. So 100 upon pi, that 31 point. Okay. Hello. Okay.
Yes,
Can
sir.
we
Yes.
can we move to next? Like you can find that magnitude from here, that directly 150 scale. If
Yes, yes, yes.
okay. So
These all calculations are very large.
yeah, yeah. And same like in that, can we find out what is that frequency? You can find out like directly from 1 upon 2 pi RC or cutoff gain frequency.
FC.
Mhm. So when you move to next, like then that is simple question. Three kilo ohm, 0.1 microfarad. Kilo ohm. So in this everything is given. So we have to find out the magnitude of the voltage gain. So can you tell what is the formula of voltage gain like that?
It is V0 by Vi.
V0 by Vi.
Yes.
Yeah. So V0 by yeah. So can we use KCL here also from here to here? We can take it as Vx. Can we do with that? Or
Yes,
you
yes.
want any other? So that's same Vi minus Vx upon 3 kilo equals to Vx minus V naught upon 0.1 microfarad that we can use 1 upon CS.
That will be parallel to.
I am writing that. I am writing parallel with the
Yeah, yeah.
60 kilo. Okay, an issue with that. So Vx will be 0. I can put directly V. So Vi upon V kilo ohm equal to V naught upon that is 60 kilo ohm into 1 upon CS upon 60 kilo ohm plus 1 upon CS. Okay, so that firstly we can solve this only like 60 ohm CS 60 ohm CS plus 1 CS. So this will so it will 60 kilo ohm upon 60 ohm CS plus. Okay, any problem? Like,
No, no. Okay.
so that Vi upon 3 kilo ohm equal to Vi upon 60 kilo ohm 60 kilo ohm into CS plus 1. From here Vi Vi upon V equals to 3 kilo ohm upon 60 kilo ohm. Downfall that will come upward, that 60 kilo ohm plus into CS plus 1, that is
Yes, yes.
60 kilo ohm CS plus 1. That kilo ohm we can cut directly, that is 320. So 1 upon 20, 60 into 10 to the power 3 into C value is 0.1 microfarad. 0.1 into 10 to the power minus 6, and S is omega G plus 1 plus 1. So 120, 60 into 10 to the power minus 3, that is 10 to the power minus 7, 10 to the power 4, so 6 into 10 to the power minus 3, 10 to the power minus 3 into omega J plus 1. So omega will be 2 pi f frequency. Frequency, how we can find? Can you tell? 2 pi RC.
Yes, yes. 2 pi RC.
So equal to 2. Frequency we can put a 1 upon R 2 by RC. Wait. Omega So frequency is 2 pi upon RC now. Right. Omega is 2 pi. F frequency is 1 upon RC. Okay. Any issue in that?
Omega equal to 1 by R.
2 pi. Oh, sorry, that too. I am also in that. Directly above the yes, 2 pi RC. That's one. So that value of R is 60 kilo ohm and CM 0.1. 1.60. To the 3.6. To the 4. 166. 0.6. Question that we bomb is control 1 into x 10 to the power minus 3 into 6.6 plus 1. So this calculation 26 30. So this we got goes 166.6 into 6 and then this 3 that is here. Exactly he was okay. Understand that.
Yes, yes.
So next question. Let me check any question. So this is the question. Like, firstly, can we check cutoff frequency? Hello.
Yes.
So firstly, we can check cutoff frequency. So what is the cutoff frequency? Can you tell?
FC that will be.
That is same 1 upon 2 pi RC.
Yes, yes.
So that R is 40 kilo ohm, and then so 1 upon 2 pi 40 kilo ohm into C 0.1 microfarad. So 2 into 40 into 10 to the power 3, 0.1 to 10 to the power minus
We have
6.
to find cutoff frequency here. What is the
Yeah,
question? Only cutoff frequency.
cutoff frequency and that is same transfer function we have.
Okay, 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 okay.
So that is 1 upon, that is 10 to the power 4 and 10 to the power 6, so it is 10 to the power 3 and round only to 5. It is 1000 159 to 3 hertz. Okay. And for that transfer function, we not we use that same for the KCL. That
Yes, yes, all
that
are okay. So,
so from here we take VI, Vx. So VI minus Vx, VI minus Vx upon 1 ohm SC plus value of 1 kilo ohm 1 kilo ohm equals to Vx minus V naught upon 40 kilo ohm. Okay. So see, Vx will be 0 because it is grounded. Or we can take like we can do it that next question. We can change the value of Vx. So Vi upon SC. So you can solve that same
yes, yes,
steps
yes.
with.
Same or like.
So can we move to like second order?
Yes, sir. Yes, yes. You can move.
Okay, let me check one question. So the basic diagram of that second order pass filter. So this is our basic design of that register. That is VE. And here also it is C1, C2. Then these are let's take molar or same. And that is P note 1. That is P note 2. Okay. So this is our basic design of that second order. And I show you. Then it is so this is its sign. The first day. So you can you tell that the what is the ratio of V naught of in values of S, 1 V high in values of S? Can you tell? Hello, am I audible?
-1 by
Hmm.
1 plus SRC2
Is 2 plus SRC2
plus S square R square
R square C1
C1
C2.
C2
Okay. Yeah.
S S
So this is our basic like, or you can do it with KCL like that is too lengthy for them. So you can learn.
yes, yes.
Hmm.
These all
So
problems are very lengthy, and
hmm.
calculation is also very lengthy, na?
Yeah.
Time taking,
Hmm.
time consuming,
Yeah,
very
the
time consuming.
lengthy calculation is.
Yes.
So and like for the first question we can do like it is basically we can find out pole frequency. Can you tell what is the pole frequency? In which signal is given as 0.1 microfarad. C2 is given as 1 nanofarad and all R is given as 10 kilo ohm and that input signal is given as 4 sine 1000. Can you tell now what is used for pole frequency?
Omega P equal to
Your voice is not clear.
1 by R root over C1 C2.
Okay, yes. If R is like R is not same, then what we can use? Different R.
Your voice is breaking. I can't
Hello.
hear you.
Now am I audible?
Yes, yes, yes. Now audible.
Like this is the formula when our resistance are equal. When all resistors are not equal, then what we can use?
Uh, then it will be
Then
R1, R2.
it is, I think we have to do like with derivation only, that we have to find that R in total R equivalent in form of R with DC signal. Like
Okay.
hmm. So 1 upon R is given as the 10 kilo and let's see 0.1 into 10 to the power minus 6 into 10 to the power minus 9. Okay, so that is total 6 and 16. So it will be 10 to the power and 6, 15 and 16. So it will be 10 to the power 8 upon 10 to the power 4 is 10 to the power 4 hertz 4 in, or we can use as 10 kilohertz. Okay. And you tell like, what can you tell what is the formula of quality factor for that same? Hello,
Yes,
hello.
yes.
So can you tell like what is the formula of quality factor for that same?
Quality
It is
factor.
it is I think root C1 by C2.
Yes, yes. Root over C1 by C2.
Then root C1 is power 0.1 microfarad. 1 into 10 to the power minus 900. Okay. So it is 0 10 to the 10 to the power 2 when we solve finally. So it will come 10. Okay.
Yes.
And can you tell like that formula for that V naught 2 upon V naught 1? That is V naught 2. That is V naught 1. Like, oh, sorry, VI ratio between VI of V naught 2. So for that, so V naught 2 upon VI become S upon omega P plus 1 S square upon omega P square plus S upon omega.
V naught 2, we can write V0 equal to minus C2 by R into V naught 2.
Wait,
Yes, no?
can you tell again?
Uh,
V naught 2?
V0, yeah, V0 with V naught 2, we can write V0 equal to minus C2 by R into V naught 2. That is V naught 2 equal to
Mhm.
minus RC,
So you are
RS
telling
C2 V0. That will be, no?
V naught 2 is minus. Can you tell again?
I am telling V0 with respect to V naught 2.
Hmm.
That is V0
V0 is
equal to
hmm,
minus C2 by R into V naught 2.
minus.
That is C2, that is
Hmm.
1 by
Then
R is C2 in
one.
V2.
Hmm. Hmm. So we can do it that. That is easy. Like that. I am telling that is told by that sir indirectly like that like
Okay,
by
okay, okay,
derivation.
okay, 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 okay. Please do.
So that is the formula for that. and one is that one
Write
more
the equation for 1, then V0 1 by
let
Vi.
of it. For V1, I think for V1 we can find directly with that, no? We can use that first amplifier. We use that only first order equation.
Okay, okay, okay.
Hmm. And then one ratio is that like one V naught 2 is equal to Vi plus V naught upon 1 plus SCR. One distance measure V naught 2 equal to V initial plus V naught upon 1 plus SC. This is done by sir in like week 6, second or third lecture. You can check if you want like derivation. You can check from. Hello, hello.
V naught 2 equal to
V
Vi
naught two
plus.
V naught 2 equals to Vi plus V naught upon 1 plus SCR.
Okay.
That is done by sir in like I think second order derivation in part 2 or part 3. I think
Okay.
so. You can do all type of questions related to this like second order. Now it is hello.
Yes, yes.
So like one type of that which signal is also so this is Pi R1. Here is one type capacitor C1. Here is one resistor. Here is one C2 and here is that that same as like we can take R4 for R R1 R2 like we can let's take both as R. Okay, you know about this and this take me you can take this as R2 C1 C2 and this is medium this is medium positive. So you learned about that. You checked like any question. Hello.
Yes, this is Roche filter, na?
Hmm. So you can tell like what is the ratio
I
here is value V naught. Hello. Can you tell what is the value of
V naught equal to minus Vi by, that will be
minus
written Vi by
S, S
S,
square
S square R1 R2 C1 C2.
hmm, R1 R2 C1 C2. It is directly like
Yes, yes.
and that one the value of like HS that signal. Can you tell that also?
HS equal to 1 by
1 upon S
1
square
upon
upon omega
S.
p
Yeah, yeah. S square by
omega p
square
omega p
plus
square
S
S
by
upon
omega p QP plus 1.
and that omega p here is omega p value of omega p square is 1 upon r1 r2 c1 c2.
Yes, yes.
That is correct.
Yes.
And can you tell that what is the voltage at that point?
Uh, Voltage at uh,
Like we can tell it is px here. So that formula for Vx is like you can do it with KCL, but it's too lengthy. Like if you want to,
yes,
like
yes,
we
yes.
have made three equations and not two, but it is like so that for it is S C2 R2 upon S square upon omega P square plus S omega P Q P plus
Plus one.
1.
Yes, yes.
Okay. So these are the like basic filters I think till week 6.
There is
Or
another one, na Sallen key structure.
that one C1 and C2 in that like in downward they're only C1 and C2.
Yes, yes.
Wait, I might also that. That is K minus 1 into R. That is R. There is C1, which is on the C2. That is R1. That is R. That one. So for that equation we know upon Pi will be, can you tell? K upon like that is 1 plus S into R1 C1 1 minus K plus C2 R1 C2 R2 plus that SK R1 R2 C1 C2. It is correct.
Yes, yes, correct.
So that is same or any other thing else like anything else like from that side.
No, no, it is. Then what is the voltage at that point? That is Vx. Here is also a Vx. No?
Here
Not
is that
at
one.
not starting point. That is.
Yeah, that one.
Yes, 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 yes.
So we can use the KCL here also. Like that is we have taken. We have to find firstly this voltage here. Like we have to find that voltage. Let we take VA. Then here is that same VA. So that
Yes,
current will comes from that side will come. in that side and that's so we have to find total that
Find.
that
Okay,
that's
okay.
that is v out here we can because this is connected with v out
Yes, yes.
so v out va and so, or we can use like for va like we have to make three equations here so one is here that va of that like that from there and gives like v from where we can like v and v out in the equation in form of v and v out. Like, can I tell or you can do?
Yes, yes, I can do.
Okay. And now anything else like related to this?
No, no, all completed here. No?
Hmm. So wait, I will ask or we will like sir had done tutorial question solutions like week 1, 2, 3, 4.
No, week from week 5, 6, no
Hmm.
question was solved. That is
Now from week 1, 2 you have done tutorial question solution. Week 5, 6 I will now prepare like in tell.
tutorial. I have We have done practice assignment. Then
Like if you want I will solve like that tutorial questions of week 1, 2 like and in next session week 3, 4 like that in that format next Saturday.
no, no. I need to today. I need to do week 7 because we have to submit week 7 graded assignment this between
Okay,
12.
so to
So
true.
we have to. I have to need to solve practice assignment of week 7. Uh,
Okay,
no need for week 1. Week 1 to 4. No need for me.
okay.
Uh,
So I
only
wait.
for
I will ask from sir.
okay, okay,
Then we will do end the session.
okay, okay. You can end the session.
Wait, I will ask from sir. Like if
Okay,
they
okay,
tell.
okay, okay,
Hmm.
okay.